Greetings, everyone, and welcome to the 2021 Arkansas GIS Spring Meeting. My name is Chad, and I'll be your host today. I'm also joined by our panelist, Deano Traywick, the chair of the Arkansas GIS Users Forum and the GIS manager of the City of Fort Smith Utilities. Also, Elizabeth Bowen, vice chair of the Arkansas GIS Users Forum and project manager, regional planner at the Northwest Arkansas Regional Planning Commission. Brian Culpepper from the Center for Advanced Spatial Technologies at the University of Arkansas, and Daryl Allen with the City of Hope, the GIS and Technology Coordinator, as well as Paige Lott with the U.S. Army Corps of Engineers. So a look at our agenda today. This is actually our first virtual spring meeting. We've hosted a few webinars to date, but today's environment is a little bit different. The idea was to host a meeting with the same type of live interaction as we've all experienced with our in-person meetings. So today's meeting is being hosted as a full-on virtual meeting instead of a webinar. Of course, the purpose and the focus is the health and safety of all of the Arkansas GIS users. Our agenda looks as such from 1 p.m. starting with a welcome from our chair, Deano Traywick, followed by a presentation from the Arkansas GIS office, as well as Dr. Rauf Hussein with NIS. Rusty McAllister and Jeff Presley will present on the Jonesboro tornado. We have a video message from NEI from Kevin Cormier, Craig Best with the U.S. Census Bureau, Chase Fisher with ESRI, Robert Reed from ARDOT, Square Peg, Round Hole, and finally the meeting wrap-up. So the Q&A today will operate a little bit differently. For those of you that have joined us in the past on our webinars, there's been a Q&A function where you could type your questions and we would read them and answer them back. You can still do that today. You'll have to use the chat option, but the idea behind today's meeting is to give everyone, again, that same type of live interaction like we would have experienced if we were meeting in person today. So we would encourage you all at the end of the presentation to feel free to unmute yourself and ask your question to the presenter in the time allotted. Oh, and the prizes. So we're not just going to wait till the very end and give away a prize or two. We've actually got enough prizes today to do a prize drawing after each presentation. And so you can expect to win either a $25 Amazon gift card or a prize donated by our sponsor, ESRI. Again, it's going to take place between each presentation and before the announcement of the next. It is now my humble pleasure to introduce the chair of the Arkansas GIS Users Forum, Mr. Deano Traywick.
Thank you, Chad. I appreciate that. I want to add on to Chad and just appreciate everyone being here. It's been a heck of a year. We had the spring meeting planned last year and just didn't work out with the COVID restrictions, and it's a little bit late to get that all set up. So unfortunately, we didn't have a spring meeting last year. But now then this year, we're still under a little bit of health advisory. So we wanted to join in with the virtual environment just so everybody could get together and just have a spring meeting in virtually. I want to go ahead and thank our sponsors with ESRI for contributing, NEI, GPS, and Nelson Intelligence Solutions. I want to thank all of them. Appreciate their support during this time. First off, I want to go let everybody know who the executive committee is. We have the planning committee for the spring meeting, but we also have a larger executive committee, and that's Brian Culpepper, Cody Massery, Daryl Allen, Eric Nelson, James Holly, Dr. John Nallen, Tyler Post, Jonathan Duran, Linda DeMasi, Paige Lott, Rusty McAllister, Scott Alsbrook, Sharon Hawkins, Sunny Farmahan, and Tina Thompson. We also have 2 federal liaisons with Tammy Hillcutt and Tina Rotenberry. Definitely appreciate all that they contribute, because we couldn't do this planning for the spring meeting or for the symposium or any of these events without their help and their commitment. These are all volunteers, and I truly appreciate their work. So because of the virtual environment, we've done a GIS Day event last November. So we had 6 presentations. Those presentations can still be watched at arkansasgisusers.org. Those are recorded and archived there. So they are still free for everybody to see. We also have been doing the forum webinars, what we affectionately call Webinar Wednesday. And these have been on the 3rd Wednesday of the month. In January, we had data-driven response to the COVID-19 emergency in Arkansas by the Arkansas State Parks. February, we had the use of geospatial technologies in response to COVID. The cast presented on their research. March, we had the GIS and Arkansas Crash Analytics Tool, or ACAT, and that was presented by ARDOT. Of course, today we're having our spring meeting. It coincided with the 3rd Wednesday. In May, please stay tuned for that announcement very soon. Again, you can watch all these recordings at arkansasgisusers.org, so please visit that. I do want to make everyone aware for the symposium coming up this fall is September the 13th through September the 17th in Jonesboro at the Embassy Suites in the Red Wolf Convention Center. It's going to be a great time to get back into seeing everybody in person. We're planning for a full event with a full conference and workshops. So I definitely want everyone to make those plans to be there and enjoy the time that we're going to have together. One of the things, if you're not a member of the listserv or the forum, I ask that you go to our website, arkansasgisusers.org, and sign up. You can join the listserv, you can get on the mailing list, you can keep up with the announcements. There's job announcements that we post, there's news and happenings that you can see there. So please join us and stay informed and stay part of the community. Also, you can follow us on our Facebook, Twitter, LinkedIn, and our website. So I just ask everyone to stay involved. I'm ready for today. I'm ready for this to be a great event. We put this on just to provide back to you, which is what we're here for. So as Chad said, please enjoy, please ask questions if you need to, and ready to get involved. All right, Jonathan, I'll go ahead and turn it over to you. We have Jonathan Duran with the Arkansas Geographic Information Office. He will give us some updates and provide us some details on what they've been working on.
Thanks, Deano. And just as a quick check, just to make sure that everyone can hear me okay.
Yes, we hear you.
Good to go? All right, thanks a lot. Did want to mention that typically this update from our agency would be brought by Shelby Johnson, our agency director and geographic information officer for the state of Arkansas. But he is tied up pretty tight right now with some of his duties with the state 911 board. As you recall, the state geographic information officer is by statute a member of the state 911 board that was created a couple of years ago. And I'll mention a little bit more about that in a few minutes, but Shelby sends his regards and apologizes for not being able to make the meeting today. You're all familiar with the work our agency does, and so I won't belabor those things too much, but I do want to mention a few things of note that we're working on and particularly spending a lot of time with recently. Very quickly, as you know, the 93rd General Assembly is still in session right now, and there are several acts that we've been tracking along the way. Most of those have to do with something that overlaps the work that we do. For instance, we pay particular attention to things that would affect the annexation processes or 911 or voting precincts, school districts, any of those types of things that there's a map or there's data involved with, we pay close attention to those. And of course, that's ongoing now, and we are somewhat expecting that they will go into recess toward the end of this month, but that's yet to be seen. And then moving along, and I'm going to share my screen, and if there, you should be able now to see it's actually House Bill 1929, because I wanted to mention one of the things that we are very heavily involved with this year, and of course likely every 10 years, would be the redistricting process. Typically the first thing that happens with redistricting, and the first of those processes, is the redrawing of our 4 congressional districts. Due to the pandemic this year, obviously the census, the entire census timeline in their calendar was really thrown off, and typically we would have already had the redistricting data. This year it's going to be much later than normal, and we're actually expecting we're not expecting the actual redistricting block level data until September 30th. And so that's why what we expect to happen this year is that the General Assembly will recess and then come back into session probably maybe in October, in that time frame, and they'll take care of those 4 congressional districts. But if you do want to track that, that's House Bill 1929. Right now it is what you refer to as a shell bill. There's really not much there other than the purpose of the bill. The actual what the Census Bureau calls apportionment counts, which is the total population for the state of Arkansas, their last timeline was that should be available on or around April 30th, and that would give us the total population of the state based on the 2020 census, and then that's what determines each state's representation in Congress. And so moving along, one of the other things that we have spent or are spending a lot of time with right now is 911, particularly the preparation for next generation 911. And I'm going to shift the map that I've got on screen to that one. All right, now you should all be seeing a map that says emergency service zones at the top. So one of the things that the 911 board is statutorily tasked with is implementing next generation 911. And if that's not necessarily a familiar term to you, it's really a revolutionary change in the way the backbone or the background 911 system really works. 911 today is all based on the same technology that was hanging on your parents' wall or your grandparents' wall, 20, 30 years ago, and that kitchen phone with the 10-foot cord and plugged into a copper wire on the backside. That's really still what 911 is based upon, is built upon, and the telephone companies have sort of made things fit for a number of years. Well, next generation 911 switches all that to an IP-based system, an IP network. And I mentioned that Shelby is working on some things right now. The 911 board, not too long ago, released an RFP for implementation of what's referred to as the ESI net, which is that IP network for 911, and next generation 911 core services. And those RFPs are being reviewed as we speak right now. Excuse me. And so, like I mentioned, the 911 board is tasked with implementing that. And as a part of that, our office has an agreement with the 911 board to develop the initial statewide GIS data layers that will be used as part of that system. If you think of next generation 911 as a truck or a vehicle, the GIS data layers are really the engine that runs that vehicle, not the least of which are the PSAP boundary layers. And we currently have statewide PSAP boundary layers, but for the most part, they are based on county boundaries or city boundaries. And we know, and you know, that call taking and emergency dispatch is not necessarily limited to those sort of administrative or artificial boundaries. Oftentimes, because of maybe the way the phone networks are set up, or just due to access, it's easier for one county to respond to a call in an adjacent county, simply maybe because you just can't get there from the other county. Maybe that's due to a lake, as you see in these maps, or a mountain or a river or whatever it might be. And so of particular interest, like I said, PSAT boundaries are one of those we're developing. In addition to those, a statewide law enforcement data layer, statewide EMS data layer, and doing some work on the currently existing statewide fire districts layer. And one of the key things to remember about what we're doing is the data layers we're developing, excuse me, are really about efficient dispatch, not as much about jurisdiction. One of the examples we always use is the Hollow Bend area. So that's actually part of Pope County, but it is totally cut off from Pope County by the Arkansas River. Right now today, if something happens out there and a 911 call is made, the first law enforcement personnel or ambulance or whatever it might be is actually coming from Yell County, not Pope County. And so those are the types of things we have to build into these maps, because it's really about getting the asset there in the quickest amount of time possible and most efficiently, because obviously these come down to obviously life and death decisions and situations. And so one of the things we're doing right now is we've created those statewide layers, and we're going around the state with a series of meetings and visiting the various counties and our PSAPs. And the way we're doing it is very old school, and really the way we tend to think about things. What you see on the screen there is a map. Those are Van Buren and Cleburne counties, I believe. And we print these off on 4x3 sheets, take these to the counties with a handful of Sharpies and say, here's what we've done so far. Y'all draw on these and tell us what needs to be changed. And so the map you see in front of you is one of the ones we would have taken to a meeting. And then this one, as you can see with the markup, these are edits that one of the folks in Van Buren County in this instance made to let us know what needed to be changed in those data layers. So like I said, very old school by the way we do a lot of things, but it's been very, very effective so far. And just to give you another example of one of these, this one I believe is in Carroll, Madison County area. Again, one of the maps we took to the meeting. And same map that we came back with those edits made on there. And so I will mention, I'm going to bring up, I mentioned that we have these meetings scheduled out through the end of the year. Now you should be able to see part of our meeting schedule. I've rolled it up to May because we're obviously about to wrap up meetings in April. We've got these things scheduled all the way out through the end of the year. And I won't go through this entire list, but I'll mention that if you are associated with a county or a city and have some crossover into the 911 data, and you want to know when we're having one of these meetings in your county, get in touch with me and I can definitely let you know. But these will be scheduled all the way out through December, and as you can see there, our last meeting tentatively scheduled for December 8th would be with Benton and Washington counties. Of course, these dates are tentative because we have occasionally had to change one for one reason or another, not the least of which was a major snowstorm in the state that we had to reschedule two of these meetings. And lastly, one thing what I wanted to mention, if I can bring this up. So one area of work that we're particularly proud of in the agency is some of the work with the Division of Land Surveys. As you recall, about 5 or 6 years ago, something like that, the Division of Land Surveys was merged into the state GIS office, which was quite a revolutionary concept, given the opposite sides of some discussions that GIS folks and surveyors end up on. But it's been a really good fit for both agencies. One of the things that the division is doing right now, if you see on this map, it may be hard to see, but there are, you see some blue dots, should see some blue dots and some green dots. Those blue dots are certified corners that have been done by a surveyor or surveyors in the past. What we're doing now is going back to a lot of these corners that are in the ground with precision GPS equipment and getting really good coordinates on those. And these are done to the NGS spec, which I believe is like 0.6 feet, if I recall correctly. And so just to give you an example, this map that you're looking at, you can get to this map by going to surveyor.arkansas.gov, and then there's a link for GLO map. But you can see that here, there's information about that corner. And then there's a link here where you can see the actual original corner certificate that was done on this one. This one looks like it goes back to, I see the date, 1988, and there's some that go well back before these. But this is really valuable information to surveyors. And one of the things that we are doing as a downstream use, as far as the GIS data is concerned, is we are using these high precision coordinates to adjust the PLSS data, the section lines that we have and are downloadable, and really adjusting those corners, those lines to positions that are very, very accurate. And so that, like I said, this is some work we're really proud of. We were able to just last month fill in a vacant surveyor position that we had, and the gentleman that's working on these now, as he works through these, you'll see these dots turn from green to blue. And I think our state surveyor told me this morning that he had processed maybe 74 or 75 of those in the field, and those obviously have not all been updated in the map yet, but they will progressively. Another area that's been worked on recently, as far as the county line, is the county line between Garland and Montgomery County, just south of Lake Ouachita. So that'll be another one where we're able to shift the county boundary in the data to a more accurate, much more accurate position. Those were the main topics I wanted to hit on for today in the main updates. And at this point, if anybody has any questions about any of those, or if there's something you might want to know a little bit more detail about, feel free to chime in and ask those.
Is anybody asking anything? Yeah.
I haven't heard any yet.
Okay, I do have a question. This is Judy over Benton County.
Hey, how you doing, Judy?
Pretty good. Why are you using the paper maps when a lot of us are already using ESRI shapefiles?
But quite frankly, because most of the folks we're visiting are not.
Oh, okay. Yeah, that was my question.
Yeah. So when in December, when we get to Benton and Washington counties, I would fully expect that we would reach out to folks there and get as much of that data as we can going into that meeting.
Oh, okay. Thank you.
So Jonathan, Elizabeth Bowen.
Yeah.
Question about the survey data, the PLSS project that you have going.
Yeah.
In Northwest Arkansas, Benton and Washington County, through the Regional Planning Agency, paid to have several survey points collected, but in looking at your map, I do not see any of those. Is there a reason why?
Well, the map that's on the screen right now is only showing part of Crawford County.
No, I went to the website and was looking at.
Specifically, I would, and I won't move the map that I have on screen right now because it can be a little slow to redraw. But specifically on those, I can take a look at those and get with Daniel Phillips, our state surveyor, and find out what might be going on or missing there.
Okay, thank you.
If there are no other questions, I'll give
Hey, Jonathan.
Yeah. Hey.
This is Sam from Washington County Planning. Hey, I guess my question is, do you normally get all paper maps being done manually, by the folks, and you go back and edit the shape files to make them up to date? Is this what's the purpose of the paper map basically?
And I'm assuming you're talking about the 911 work?
Yes, yes, sir.
Yeah. In most places, the things like a law enforcement data layer or EMS data layer, in most places, those data layers just don't exist. And so we actually created those two statewide versions of those two data layers from the best information we could get. And so what we found, I mean, obviously there are electronic and on-screen ways through web maps and things like that we could open up and have people go in and edit. But what we've found is that laying those maps in front of people really gets them involved and really makes them feel like that they are, their input is valuable. And so it's as much of a coordination effort as anything. And so we can put those maps in front of them, and we're there with them, and we've identified areas that that we think need to be addressed in some shape, form, or fashion. That Hollow Bend is a perfect example. It's a really visible and familiar example where right now the PSAP boundary layer that we have for Polk County follows the county line. Well, in reality, even today, that PSAP boundary should essentially follow the Arkansas River instead of the county line. And right now, the PSAP boundary it's really only a map data layer that is just used like any other map data layer. But going forward, why that's going to be critical is a PSAP boundary layer is what will determine how the calls are routed in the next gen system. So that's why that layer is probably the most important of any of them to make sure it's correct.
Thanks, Jonathan.
Yeah. Jonathan, Elizabeth Owen again. One more question. On the PLSS project, do you still have funds available on the cost share basis that you did, 2 and 3 years ago? That different entities?
Not right now.
Okay.
Yeah, not right now. And of course, we're winding down into the end of the fiscal year, as everyone knows as well. So, but yeah, not at this time.
So have they just been used up for this year, or you are not budgeting for anything?
At this point, both.
Okay. All right. Thank you.
All right.
I certainly appreciate everyone's time. And with that, I will turn it back over to Chad.
All right. Thank you, Jonathan. Appreciate everyone's questions and everyone's involvement. And now, time for a very exciting feature that everyone looks forward to, the drawing of a door prize. So in classic fashion, we're going to use the random number generator and the list of attendees. This is not in any order. Well, I guess it's actually in the order that people registered. I have set the parameters for the total. So today's drawing, since everyone is interactive, you must be present to win. The first drawing will be for a $25 Amazon gift card. So imaginary drum roll, number 132. Is Rachel Worthern with Arkansas Game and Fish Commission. Are you on, Rachel?
I am here.
All right. Well, congratulations. You are our first winner.
Exciting. Thank you.
You're absolutely welcome. All right. So back to the agenda here. So our next presenter will be from Nelson Intelligence Solution, Dr. Rauf Hussein. Dr. Rauf, are you available?
Yes, sir, I am available. Thank you so much. Let me share my screen. Can you all see my screen?
You are good to go, sir. Take it away.
Can you hear me well?
Absolutely.
Great. So hello and welcome everyone. I am Rauf Hussein. I am a GIS geotechnical engineer and I am working for the Nelson Intelligence Solutions. So today I am going to talk about streaming and real-time location tracking with the Arcgis GeoEvent Server and the Arcgis custom web applications. This is my outline, and today I am going to talk about my organization, and then I will jump into the main topic of this presentation. In the main topic, I'm going to talk briefly about the base Arcgis enterprise components, the Arcgis GeoEvent Server, and the Arcgis web applications, and this is the developers edition. Then I am going to show you how to input and output data using the GeoEvent Server. I am also going to show you how to visualize stream data. In addition, I am going to talk about geofencing and how do we store real-time data of interest. Moreover, I am going to show you some of the web application capabilities. And finally, I am going to show you a demonstration of the created applications. So let's get started. In 2016, Nelson Intelligence Solutions was formed as a service-disabled veteran-owned business with offices located in Stafford, Virginia, and Little Rock, Arkansas. I am presenting from Little Rock, Arkansas. NIS does business as a defense, information, and intelligence firm with an emphasis on federal government work, particularly in support of the Department of Defense and state and local governments. NIS's main service sector includes intelligent analysis, geospatial production, providing on-site personnel services, and IT support with various clients. NIS is a silver tier partner with ESRI and an ESRI federal small business specialty partner, and this helps deepen our GIS and mapping skills and expertise. NIS can successfully support the investment in the production of Arcgis web applications, hubs, websites, dashboards, smart forms, story maps, indoor maps, and interactive 2D and 3D maps that will be developed to help solve problems, make better decisions, and take actions. So now let's jump into the main topic of this presentation. So what does streaming and real-time location tracking require to work? The first thing is deploying the base Arcgis enterprise on a local machine. The base Arcgis enterprise consists of 4 main software components. We have the Arcgis server, we have portal for Arcgis, Arcgis Data Store, and the Arcgis Web Adapter. So the Arcgis server is a back-end server software of the Arcgis enterprise that makes your geographic information available to anyone with an internet connection. This is accomplished through web services, which allow a powerful server computer to receive and process requests for information sent by other devices. The Arcgis enterprise portal allows you to share maps, scenes, applications, and other geographic information with other people in your organization and public. With the portal, you can search for GIS contents, share links to GIS applications, do analysis, and share maps and layers to use in Arcgis Pro or ArcMap. The Arcgis Data Store is an application that lets you configure data storage for the hosting server used with your portal. There are 3 different types of data stores. The first one is called relational, and this one stores your feature layers. The second one, we have tile cache data store. This one stores your scene layers. And the last one, and the most important one for the streaming, is called the spatiotemporal big data store. And this one archives real-time data from a GeoEvent server site. So when installing the data store, by default, the relational and tile cache data stores are checked and selected. For streaming and real-time observations, you need to select and install the spatiotemporal big data store as well, this one. The Arcgis Web Adapter allows you to integrate your Arcgis server and portal with your existing web server. For example, by using the web adapter, you can integrate your portal and server to your Internet Service Manager on Windows 10. You need to install two ArcGIS web adapters, the first one for the server and the second one for the portal. And this is an example to a URL with a web adapter, without a web adapter. And you can see here is the port number. And this one with a web adapter, you don't see a port number here. This one is more secure to share it with other people. The ArcGIS GeoEvent Server enables real-time streams to be integrated to your enterprise GIS. Then data can be filtered, processed, and sent to multiple destinations, all in real time. Next. So what we need to do is we need to use the developer edition of the ArcGIS web application. These applications are user-friendly and can run on different platforms like smartphones, tablets, and computers that have a browser and an internet connection. In our case, for this presentation, we just need a smartphone with an internet connection. You can easily scan a QR code or use URL to view the application. These types of applications contains many widgets to easily create a web app. As I mentioned, for streaming and real-time location tracking, we use the web app builder for developer edition because we need to update the code behind some of the widgets and create our own ones. You need to create a new widget for streaming and update the code behind it. According to ESRI, at a minimum, 2 files are required to create a widget: a JavaScript file that defines the widget and a manifest file that describes it. These are the default codes for a base widget, and you can copy these codes from the ArcGIS developer's website. Your own code goes here. You just need, in your own code, you just need to use the watch position method of the geolocation API to get X and Y coordinates from the browser and the GPS of the cell phone, for example. And then you need to post those data to the GeoEvent server using the fetch API. Next. Working with streaming and real-time location tracking. This work is performed in the Arcgis GeoEvent Server. So after installing the Arcgis GeoEvent Server, you need to access the GeoEvent Manager, and this is the URL to the GeoEvent Manager. You need to use the fully qualified domain and this port number, then GeoEvent, then Manager. Then you need to create a GeoEvent definition. A GeoEvent definition is the schema that identifies the field names and data types. These are 2 GeoEvent definitions were created for the purpose of this presentation. The GeoEvent definition to the left was created for streaming data, and the one to the right was created for storing the data. After creating the GeoEvent definition, you need to create a GeoEvent service. This allows you to define input connectors and output connectors. With the GeoEvent service, you can easily add filters and processors to perform real-time data analysis. A connector is made up of an adapter and a transport. An adapter interprets data formats, and a transport sends and receives data over a communication channel. For this work, 2 GeoEvent services were created. The first one for streaming data. This one is for streaming data. I named it stream service, and it takes 1 input connector and 1 output connector. The second service for storing the data of interest, which I am going to talk about it in the next few slides. These are the available input connector with the GeoEvent server. For the input connector, we used receive JSON on a REST endpoint. This can be used to receive JSON data on a REST endpoint hosted by the Arcgis GeoEvent server. These are the available output connectors with the GeoEvent server. For the output connectors, we used a send feature to a stream service. This one, send feature to a stream service. This one can be used to broadcast event data as a JSON via a stream service. We also used add a feature to a spatiotemporal data store output connector. This one is the output connector, And this can be used to save event data into a feature layer in the big data store. Once you create the output connector for the stream service, you need to publish the stream service. And if the server is federated with your portal, the stream layer will be shown in your portal. You can then save it in a map or copy its URL and add it to your AGOL or ArcGIS Pro. After saving the map that contains the stream layer, you can then use the same map in your ArcGIS web application for streaming purposes. Next, geofencing is one of the most important features in the GeoEvent Server. It's about triggering an action when one feature comes close to another one. You may want to be notified as soon as people enter or exit an area. You may also want to know the time they spend there. To do this, geofencing and filters can help store the real-time data of interest into a feature layer in the big data store. Next. This capture shows the second GeoEvent service that I talked about that was created in order to save your data of interest into a feature layer in the big data store. This service takes one input connector and one output connector. As I mentioned, for the input connector, we used receive JSON on a REST endpoint. And for the output connector, we used add a feature to a spatiotemporal big data store in order to store data into a feature layer into the big data store. It also takes filters and processors for selecting entrances and exits to an area of interest, and also for calculating the time of entrances and exits. The previous steps will bring your application to life by integrating real-time data into your web application. This capture image shows an ArcGIS application brought to life by integrating real-time data. And this custom widget was created to get X and Y coordinates from the browser and the GPS of the cell phone or any other device, and then ingest them as JSON data into the GeoEvent server, and then we can stream from the GeoEvent server back to the map used by the web application. Streaming from the GeoEvent server can bring everyday GIS application to life. The features and contents can be updated continuously and then consumed again in the web maps and applications. So with this application, you can stream data, find best routes and directions, search for points of interest, takes measurements, and so forth. Now I am going to show you a demonstration of the web application that was created for biking purposes, and everything is just a test. Let me exit this presentation. This is my application. I named it Arkansas Biking. So with this application, you can report an incident. And this is the survey 1, 2, 3 form. It's loading. It's going to take a second. You can submit it, and then you receive it in your layer. You can zoom in. You can zoom out. You can go to your current location. You can go back to the extent of the map. You can also find directions. For example, if I want to find the directions from this point into this, let me clear it, from this point into this point, the system is going to calculate the directions for you. You can also find distances and directions. For example, if I click a point here and then click another point here, the system is going to calculate the length of the line, and also is going to calculate the angle of the line. You can share your application to Facebook, Gmail, or something like that. You can also embed your application in your website. You can change the base map of your application. It's going to take some time to load. You can also find the points of interest around an area. For example, if I click the point here, the system is going to find the points of interest around that area. So you can have some information. These are test information just for test. You can have some information about the point of interest, and you also can attach a photo or an image of that point of interest, and then you can open it. You can also swipe your data. For example, if you don't want to show the data on a map, you can just remove everything. You can clear all the data to see everything on a map. You can do measurements. You can add data. You can show graphs and statistics. You can stop streaming and continue streaming again. You can show a legend. You can search for first aid. You can calculate building heights, for example. These are just test widgets. You can add a net to your location. So the most important thing in this web application is this streaming and real-time location widget. This is our own widget. We created this widget and we updated the code behind this widget. So if I open this application on my cell phone, now it is open on my cell phone, the widget is going to take the X and Y coordinates from the network and also from the GPS of the cell phone, and then it's going to ingest them into the GeoEvent server. So this is my GeoEvent server manager. These are my input connectors, and these are my output connectors. This is my feature service for storing a feature. And this is my stream service for streaming data. So you can see here, I have everything on my cell phone. It's open. You can see I am ingesting one data, and also I am outputting one data. For storing the feature, I am ingesting one data every 1 second. I am outputting just the data of interest. So let me now open my map. This is my map. I am inside the building. So if I change my position, let me change my position a little bit. I don't think it's going to change. It's changing now. Yes, I can see it. But if I change my position, you can see the bike is changing. I also created a test geofence or geometry. This is just for test. Anytime the bikes enters this area, we store one feature and we name it like entrance. We can calculate the time of entrance. And anytime the bike exits the area, we can store one exit and we can calculate the time of exit. And from this, you can also calculate the time that people spend in an area of interest. What's more, you can do the same thing, embed the same widget in your 3D application. So this is the 3D application, and this is our own widget. If you use, if you use this application on a cell phone, you will stream data to your GeoEvent server. And this is for streaming and real-time location. So now let me go back to my presentation. These are my references. And thanks for your attention. I am ready to answer questions.
All right. Thank you, Dr. Rauf. Does anyone have any questions? Like I said earlier, feel free, if you have a question, you can enter it in either the chat or ask it virtually here. We do have a comment. Very well done, sir.
Thank you. Thank you.
I have a quick question. Dr. Hussein, like this is Sam Mata from Washington County. How hard it is to use the customized widget? I mean, like, do you have to be like a programmer to be able like, to use like the customized widget or create your own, or like it's mostly, I've seen the developer like online, and like, is it mostly like cut and paste and like you can just add like your links to it, or you need to have like some background in like in programming?
That is a very good question, Sam. To be honest with you, I am not a developer. I'm a GIS analyst and I'm a geophysicist at the same time. It is the ESRI made everything very, very easy. You can just follow the steps and you can do it yourself. You don't need to be a developer.
Okay, to add to this question, do you know how much is like the registration or like subscription to the ArcGIS like developer, or like it comes with your like organization, or it has to be a separate subscription?
I am not sure about this one, but I think we have just the ArcGIS Web App Builder. I
Okay.
don't think we have the developer edition. So if
Okay.
you have the web app builder, you will have the developer edition.
Oh, okay. Nice. Okay.
You just need to
That's
install the SDK on your local machine.
Oh, okay. So I need to install the SDK. Okay, I'm writing this down. Thank you so much, man.
You are welcome.
Absolutely.
All right. Well, in the interest of time, I guess we'll move on. If anyone has any questions or follow-up feedback, feel free to reach out to Nelson Intelligence Solutions directly. So thank you again, Dr. Rauf.
Thank you so much.
All right. So time for another prize drawing. We all get so excited at this point. I know I do. Ironically, my name is in the list, so that's probably not fair, but so the next winner is number 24. Did you remember your name when I scrolled by it earlier? Number 24 is Paul Lowry, Northwest Arkansas Community College. Are you online, sir?
Yes, I am here.
All right. Well, congratulations, Paul. You have actually won a door prize donated by our sponsor ESRI, which is a gift bag containing, I have no idea what.
All right.
They're actually very close to you in Fayetteville, shipped to our fellow colleague, Mr. Brian Culpepper has them, and will deliver that possibly in person. I don't know.
No, it will be very nice items, and I'll follow up with you, Paul. But yes, thank you.
Yeah, thanks, Brian.
Brian, hook me up.
Hey, just a quick note, Brian. How many of those do we have actually?
We have 5 of those.
Okay, great. That's the number I had in mind.
And
all right,
Jessica and the whole ESRI staff are to be commended for them putting that together for us. We appreciate it. Thank them.
Absolutely.
I thank them.
We all thank you in many ways. So moving on, our next presentation will be the Jonesboro tornado, which I am told, in fact, I had a little preview from Mr. Rusty McAllister and Jeff Presley with the city of Jonesboro. It's very exciting. Technically, we're still in tornado season. Yeah. So we'll turn things over to you, Mr. McAllister. Are you available?
Are we live?
You are live. Feel free to share your screen as soon as you're ready, sir.
Did that share it?
It did indeed.
Okay, I'm sitting here with Jeff Presley. He's going to start the presentation, then I'm going to follow up. So, Jeff, I'll let you take over. Jeff is the 911 coordinator for the city, as you can see on the list.
Yeah, about 30 years in the business of 911 here in Jonesboro, Northeast Arkansas. We've seen a lot of changes in the last 30 years. One of them being the digital mapping that we now use in 911. March 28th of last year, on a Saturday afternoon at 5 o'clock, Jonesboro was hit by a tornado right downtown in the mall area. COVID saved a lot of lives that day because our mall was empty. We did have several buildings that collapsed. A lot of destruction, but the maps that day in 911 went to work right away. When dispatchers set up perimeters and we had officers on the scene along with rescue, within just a few minutes, we had outside help calling and setting up command posts. So we was able to incorporate our map with our automatic vehicle locators, set up those perimeters, get a quick snapshot of where the damage was and where our search and rescue efforts would start, along with the street closings that had power lines and power poles down and things like that. We shared this information very quickly with the officers in charge on the street with the command post. We had Truman 911 coming down to help us, along with several officers and firefighters. Greene County 911 was here within 30 to 45 minutes helping us work this command post. Very, very busy time. The response went very well. After the response and search and rescue was continuing, We was able to map along with our storm shelter registry to make sure that we hadn't overlooked anyone that might be trapped in a shelter or in a in-ground type enclosure. So over the days as this played out, we had several contractors coming into town. We worked closely with those contractors, getting certifications, making sure everybody was allowed in there. We had several people come in that helped out, from the Samaritan Purse people to the Baptist groups coming in to help with rescue and supplies. So we was able to track that information from the get-go of that tornado to the search and rescue to the recovery effort. And to this day, we still use that as one of our training scenarios. Rusty?
Okay, a couple of things that Jeff may have covered, if I can get this to work. There we go. On March 26th, the tornado was on the 20th. On March 26th, Jonesboro, very forward thinking, we planned ahead and had the city flown at 3-inch resolution aerial images. And if you believe we knew that ahead of time, I've got some land to sell you. But seriously, we did on March 26th, Sanborn flew the city at 3-inch resolution. March 28th was the F3 tornado, which, as Jeff said, did quite a bit of damage. A company called GeoIntel, the Gray Sky Disaster Response, they came in on that following Sunday, as did Eagle Forestry, but I had the Gray Skies imagery. They came in and flew the city afterwards. They're funded for insurance fraud mainly, and they provided all that data. This is a statement from them. This was the plane they had planned on using. This was at the Jonesboro Airport. And as they said, they had hoped to have the images quicker, but there was just a little bit of a problem. The pilots were in this building. If you look back here, a lot of this is aircraft that were at the airport. And as you can see, this was theirs. And this was not unusual to see aircraft in this condition out there. They did say that this one, the camera was amazingly appeared okay, but that the aircraft itself had trouble getting a pilot to want to fly it out. We were able to take the images and figure the virtual path, and I'm going to go into how we did that in a little bit. But this was pretty much the path that followed. If you're familiar with Jonesboro, this is Sam's right here, Sam's Club, Race and Caraway area. This is the airport, subdivisions, Farville Curve, and then on into Brooklyn. But that was basically the path it followed. We went out, had some of our inspectors actually go out and map the houses in the area that were hit. And you see in the bottom right, they looked at whether they were gone to just tarped, boarded and damaged, just minor damage to the state they were in. Part of what we were doing, if you were rebuilding your own house, there was waiving a lot of the fees. The old landfill was opened up for debris from the tornado damage, but it had to be a house that was in the tornado damaged area. And well, let's just say some people didn't live there, wanted to dump trash. Anyway, we had a record of all that we could look at really quick. You can see here's a little bit closer image of what was going on. This was just using the aerials for this. And then the guys going out and getting the addresses of the houses that were damaged. So we had a record of what was going on with that in the city limits. Sometimes on the aerials, a house would look okay, but it actually twisted on its foundation. But from above, the roof looked good. Some of them, you can tell they were badly damaged. You look at this aerial right here. This is an example of that. This was flown on March 26th. This was the 3-inch resolution. This is part of a subdivision. This is after the tornado. It's just amazing the damage you get. You see a house here that had almost none. These are pretty much gone. And this was that same area. This one became this. And this was just in a matter of a few minutes. It's still amazing. What do we have? A dozen or so injuries?
We had 22 injuries.
No fatalities. And I think 2 people that spent the night in the hospital, and that was it. I mean, just unbelievable still. This one is an interesting one. This is Gateway Tire. If you're familiar with them in Jonesboro, they were a pretty big tire place just across the street from Sam's in that area. Before the tornado, this one, the top half is after the tornado, the bottom half was before. Did this as a comparison of what it did to them. And you go here, this is a close-up of it. Those of us that are into older vehicles, like older vehicles, understand this was an old square body Chevy. It was in there for tires at the time. it's probably salvageable, but it did some damage. But if you're looking at aerial 3-inch resolution, you can tell the tires. These were actually early releases. I mean, it was, and this, you can still see some of the seams on some of them. But it's just still amazing. This one was an interesting one. I told you we followed the path. This was the tornado path. It edged the ground. That was most of the way through it. One thing interesting here, if you look at this photo, this is the airport down here. This is the train tracks behind it, behind the airport. The tornado went through here. Here's the train cars that were in the path. If you notice, these on the south side of the path are on the south side of the tracks. These up here are on the north side of the tracks. It's kind of hard to tell in this image because when I put it in PowerPoint, but those are boxcars laying on their side. And here's the actual track. But you can see by the rotation of the tornado that blew these north and these south. So just still kind of amazing. By looking at the houses, we were able to go into parcel data. And I know you can't read this, and I did that on purpose, but this is the parcel data. We could pull up of the houses that were damaged, photos of them, anything like that. So we had a record of all of them right here we could pull up. And I did this in just a few minutes from after they got the locations to me. And this is kind of what was there. Like I said, I've erased the owner's name. You can see this house was gone. This one was considered damaged. I'm kind of questioning that. And this one was considered damaged, which means the inspectors thought they could be repaired, the building inspectors that went out. They may not have been. This one is kind of interesting, but I know the guy that owned this house. He had told his wife that said, "You always want to see a tornado," said, "You finally got to see one." Her words were, "No, I didn't. I was in the floor and you were on top of me when it came across." So, I mean, that was just a lot of the damage we saw. He did have a pretty nice grill he never did find. He found a wheel off of it and that was it. And this is another thing that if you don't do this, is highly recommended in your cities, your 911 centers. These are storm shelters. A lot of storm shelters now are in garages, in floors. They're hard to find. There was a couple up here in the area, not a whole lot in this area. But to map those and then know where they are if you have to search for them, this is what we have one like this is at 301 marked. I have a lat long and I have a description of where it's at. And Jeff can probably tell you a little bit more about why we first started that project.
Yeah, the reason we got into the registry for storm shelters was right after the Joplin tornado. A couple stories come out about the search and rescue. Some folks that was actually trapped in shelters that nobody knew were actually in that place. So with GPS coordinates, if all the landmarks are gone, we still have a good point to start that search and rescue.
Because if a house comes down on those, you're not going to know they're there. And this is a little video. This is one of our traffic cameras. If you're familiar with Jonesboro, this is looking towards the Sprint store at Red Wolf and Highland. Keep your eye on this when the video starts. You'll see their power goes out. And I think we cut the video short. There was a guy stopped his truck right here. He got out, then went back to his truck and then got out again and ran into the gas station that was here. But you'll start watching, you'll start seeing people turning and then realizing there's a tornado and trying to U-turn out. And it's pretty amazing there wasn't a wreck from all that. So let's start this video for you. And if you watch the top left, the power is just about to go out. And they're flickered, then it went all the way out. And you're watching people, these people are running from it. They finally hit the point they're disregarding the red lights. You see people down here changing lanes. Same thing up here, they're making U-turns, realizing that they're trying to get out of it. These people here are trying to get away from it. And as you see, it's just amazing they didn't run into each other. And now you're seeing the tornado come across up here. You start seeing the lights shake and you see a little bit of debris falling down. And then the power went down on the cameras. I can tell you, I live north of here, about 16 miles. I came through here maybe 20, 30 minutes before the tornado hit. I got home we were watching the weather, and I did what you're supposed to when you got a severe weather warning. I went out on the porch and watched for it. But anyway, we had severe wind and rain, and then suddenly the rain eased up and it started raining debris. We were getting shingles, pieces of wood, plastic from this tornado. But you can see the tornado back here. I mean, and it literally, all clear had been issued, and the local TV station said, we don't think it should be clear. We think there's something happening, and started issuing warnings because it came up just instantly. I know the TV station here should have some videos. I wasn't able to get them. I found some others on YouTube, one really good one, but the language was pretty coarse in it.
Yeah, at this point here, we had set up police officers to watch the weather, and they started reporting damage and debris. We set the sirens off, 33 sirens in the city of Jonesboro. We actually ran them 3 times to make sure that it was getting out correctly. But we had officers that followed the storm and started search and rescue in vehicles that was overturned at this time.
But you kind of see it right here in the debris that is kicking up around it. I'm not sure where this camera was.
It's NEA Hospital, looks like. Yeah,
Maybe.
it's up there in the corner.
Yeah, NEA Hospital is up there, and it went right beside them with no damage. And there was places like Academy Sports, if you're familiar with them, they had like, I think some very minor damage to the roof or to the front of the building, but there was cars piled up at each other in the parking lot. And this is, if you're familiar with Jonesboro, there's Ace Hardware, and this is the NEA Hospital. You're looking at the tornado. This is just about that subdivision I showed you where the guy I knew lived, that his wife wanted to see a tornado.
All right. Well, excellent presentation, Rusty and Jeff. If anything, it's a really interesting look at how GIS is involved in both before and after a tornado in so many aspects. So thank you guys so much for the presentation. Does anyone have any questions?
Yeah, I'd like to say, Rusty, we were across the town from you. That neighborhood that you showed multiple storm shelters in was my neighborhood.
Oh, was it really?
And my in-laws' house was right there where the trains derailed, and they didn't total it, but the house across the street was wiped off the foundation, and most of the houses down that street where they derailed were totally rebuilt. And it was unbelievable how good the news did. They had real time. They were able to, everyone turned on the local news. In real time, they could tell you where in town the tornado was. And so they were walking us through while we were watching the videos from the university and from NEA after the university. I think first they were showing one from the stadium at the university, and then they switched over to NEA. And we thought we were going to get hit. And so we're hunkered down. And I'll say this, and this is not the forum to make this comment, but we cannot hear the sirens from our neighborhood unless we're outside. So it may just be that our houses are sound deadened really well. But I live on the hill, and the wind and the noise was so loud, of course. And now after that, it was a life event for this portion of town, and it happened in COVID. And I think you should mention that as well. Just the fact that people were not in their normal routine. And were you going to show anything else about like the mall?
Well, we're about to run out of time, but
yeah, unfortunately we are out of time. So again, thanks Rusty and Jeff and John for your feedback and input. If anyone does have any questions or feedback, feel free to reach out to Rusty McAllister at the City of Jonesboro. So real quickly right now, time for another drawing of the door prize. This time will be for another gift bag from our sponsor, ESRI. 40, Mr. Charles Mosby. Congratulations, sir. You have won a ESRI gift bag. Are you online and available? All right. Maybe Charles is not with us or no longer with us, so unfortunately, we're going to move on to another draw winner.
Hey, Chad, real quick, on the chat thing, I gave a link to Eagle Forestry's website where they can look at the tornado areas.
Okay, thank you, Rusty. Road 10, Mr. Jeremy Adams, the Arkansas Coalition for Obesity Prevention. Are you online, sir? Okay, third time's a charm, as they say, right, folks? Congratulations, Eric Bach with NEI. Are you online?
Yeah, I'm here, Chad.
All right. Well, congratulations, Eric. You have won an ESRI gift bag.
Thanks, man. I appreciate it.
Absolutely. And ironically, our next presentation is actually a video, which a portion of it does feature Mr. Eric Bach. So, wow, what an ironic world we live in. So I would now like to introduce one of our sponsors, NEI, and a presentation narrated by Mr. Kevin Cormier.
Hello, everyone. Welcome to the Arkansas GIS Users Forum. My name is Kevin Cormier. I am the Louisiana Mapping and GIS Sales Consultant for NEI and Trimble. We have a lot of good content during this presentation, from equipment, new technologies, and how we teach, collaborate, and continue to move the needle for our existing and potential customers. Stick around. Our presentation will begin momentarily.
"40 years ago, we started from up here, creating powerful paths that accelerated human potential, all the way down here. And we've never stopped. We are explorers of the possible, a driven collection of seekers who continually bring forth new ideas to support our customers and partners. Our mission is to advance the mission of others, those who are determined to challenge convention. Our vision helps companies look forward, supporting their bold thinking for new products, new models of revenue, new industries, and amazing things yet to come. We are forward-thinking, but disciplined, helping businesses reach further with innovations grounded in marketplace realities. Together, we are creating solutions that improve what is and what will be. Trimble, transforming the way the world works.
NEI is a Trimble geospatial distributor. We sell mapping, marine, and survey grade positioning products. What the Trimble brand means to NEI as well as to our clients is durability and innovation. Drop it out of the back of a truck, pick it up off the ground, put it back on your pole, and it's gonna still work. That's what that means to NEI, and that's what it also means to our clients. One of the things that's given NEI the strength and confidence to go out and do our job every day is knowing that Trimble is 100% committed to its distribution. What separates Trimble distribution from other manufacturer distribution is the localization piece. NEI works from Louisiana over to Florida, up to Georgia, over to Arkansas. There's different problems in different regions that require geospatial expertise. So in order to deliver world-class geospatial solutions, we need boots on the ground in these specific regions to answer these questions.
Our backbone is customer service. It's been that way since the very beginning. Our father believed in that. William and myself believe in that. Our employees believe in that. Our teams, we have strong relationships internally and we have strong relationships externally. We're proud to be a family business, a woman-owned business, and to work with a partner like Trimble. You know, we've come a long way together and it's been an exciting journey and we look forward to what, you know, the future holds.
GNSS constellations. This represents the GPS, or known now as the GNSS constellation. These satellites are about 11,500 miles from the surface of the Earth. That's where they need to be to stay in orbit and perform correctly. Each satellite makes 2+ revolutions around the globe in a 24-hour period. That puts them moving about 9,000 miles per hour. We now have access in the US for 4 different constellations. The first being GPS, originally Navstar, which is the US system. Next was GLONASS, which is Russian. Then Beidou, which is China. Then Galileo, which is the European system. It is also the most advanced of the 4. Here is a GPS fun fact. Although GPS is free for the entire world to use, its operating cost alone is $2 million a day. Just that alone tells you how important this technology is. It has been more than 40 years since the first GPS satellite was launched into space. And now, almost every day, all of us are using this free-to-use technology to help us go places, tell us where we are, measure vast and short distances accurately and consistently. This system of constellations has led science to experiment while helping discover the true center of Earth and also other tectonic plate movements all over the globe. The importance of accuracy. We as humans use accuracy on a daily basis, from driving our cars, judging distances with our eyes, reading, writing, typing, sending an email, speech, the list goes on and on. So why should your GPS equipment be any different? Here is a not so fun fact. Who wants to be this guy after a hard day's work of locating and proving underground assets? Not me. With the use of high accuracy GPS, you can be confident your maps will be correct, and depending on your needs or the type of asset, you can achieve meter, submeter, decimeter or subfoot, and last but not least is centimeter accuracy, basically anywhere on the planet. Let's take a glimpse at Trimble mapping and GIS data collection software, TerraFlex. Trimble TerraFlex is a fast and efficient geospatial data collection application. It works across a fleet of mixed devices from Android, iOS, you name it. You can also help streamline your data management. Keep your data organized from field to office. Work anywhere, even in remote areas. Here is an example of the different types of devices that are commonly used, either standalone or paired with a higher accuracy receiver. Whether you use TerraFlex, which is consistent regardless of the device, and it can automatically sync your data from the field to the office, or even if you use ESRI Collector and or ESRI Field Maps. Let us now take a look at how NASA and Trimble took to the skies to survey our polar caps with the latest and greatest technologies.
The Earth's polar regions are under increasing stress. Melting ice brings rising seas, causing the world to lose its bearings. So when NASA began Operation Icebridge, the largest airborne survey of Earth's polar ice, they understood what's at stake. NASA needed reliable and accurate orientation while capturing data from the most sophisticated science instruments ever assembled to measure polar ice. And so, at the frozen edges of the Earth, NASA trusted Applanix to provide custom solutions, hands-on support, and pinpoint positioning. Now, as the ice continues to shift, we're proud of our part in helping NASA capture a clear picture of our changing world, maybe even to help save it. Anywhere in the air, trust your position with Applanix.
Helping solve world problems. Such a great story to be part of. Let's take to the skies again with microdrones. NEI was named Global Dealer of the Year for microdrones, and this next clip helps to understand why.
What's great about our MD LiDAR 3000 product, it still carries on the same microdrones reliability that we've been known to produce with our systems over the last 15 years. What our MD LiDAR team in Montreal has done has been able to integrate all of these pieces into one fully integrated workflow that allows you to get feedback from the sensor real time when you're flying. So you actually build an LES point cloud for each flight line, which helps in the classification of the data. What we've also done is we're taking photos with the high resolution camera. So we're getting direct georeference images as well as direct georeference scan data simultaneously. So you can actually produce two deliverables for your end user. You have a high resolution orthomosaic as well as the high accuracy elevation data from the Regal sensor. Not only are you producing two deliverables, you're using that high resolution orthomosaic to colorize your point cloud to help in the classification process.
We usually start with trajectory data. After that, I'll move on to georeferencing the point cloud. We also have the ability to use the imagery. It allows us to do stereo compilation with the imagery along with the LiDAR data as well for our vertical information. So through that process, we have a pretty robust means of developing planimetrics and topographic features with the data straight from this one product.
During post-processing, I used the data from the MD LiDAR 3000 to use stereo images to collect features, including utilities, edge of pavement, curb backs, building tops, all for purposes of planimetric map for our clients.
Our customer base is very excited about us having the MD LiDAR 3000 system. We've been having inquiry about doing projects with a drone and have actually kind of resisted until we knew we had a solution that we could trust. Something that would give us repeatable, accurate, and reliable results. Ever since we got involved with microdrones on this project, everybody here at the office is just kind of on a buzz. It's almost been like a morale boost in the company. Everybody's really excited about it.
Do you work in remote areas where cellular coverage is lacking? No problem. RTX has you covered.
Trimble RTX is the best satellite-delivered positioning technology on the market today. Trimble RTX models the errors in your GNSS solution using Trimble's Global Reference Station network, transmitting correction data via satellite to users worldwide, providing far greater accuracy and reliability than freely available services or any other paid satellite-delivered correction service. Plus, there's absolutely no need for a base station. And because it's delivered via satellite or over the internet, Trimble RTX works nearly anywhere, even in the most remote locations in the world. Centerpoint RTX, our premier RTX service, delivers real-time horizontal accuracy in a matter of minutes. And in select geographies, you can be fully converged in typically 1 minute or less. No other satellite-delivered service comes close to this performance.
Let's hand it over to Eric Bach, who is our training and support team lead, to talk about and show us how to do offsets with TerraFlex using a TruePulse laser rangefinder.
Since I am working in Louisiana today, we are going to be using LSU's C4G VRS, but you can see in my list I have a handful of others for Alabama, Arkansas, Mississippi, and then some continental US would be SBAS, and then I have worldwide RTX. So we're gonna stick with Louisiana. Down towards the bottom, you will see laser rangefinder. Here's where I click on my true pulse. If you want to see feet or miles, you would click on imperial. Another thing too, well, not on this screen, we'll save that for Android. All right, let's go home. And I always like to go back to this hamburger icon and check my location status. And I want to verify that my accuracy gets down to what it should be. Now this is a centimeter R2. You can now see that I am 0.2 inches. So we are ready to roll. So I'm going to click on poll. All right, it says here at the top that I've collected 0.3 inch accuracy, but I want to do an offset because the feature I'm shooting is not accessible to me right now. So I'm going to click on map, the middle teardrop with the X. First thing it says to do is move to a location as your starting point and hit log. All right, it logged my position. Now I'm going to grab that laser and I am going to fire it at my object. All right, 22 feet. Now the software tells you move 90 degrees around the object, log another position. So you'll see here it's drawing buffers, circle buffers. So I'll move 90 degrees and reshoot my position here. Let me get set up, I apologize. All right, we'll get all leveled up. All right, first thing we are gonna do is hit log. And then it says, fire the laser. We fired the laser. You see now it draws 2 buffers. Tap on the map to choose the correct location of the feature. So you have those 2 dots. So basically as you walk from one to the other, is it gonna be on your left or on your right? So I'm going from the dot that says 22 foot and I'm walking towards the one that says 13. So I'll be clicking on the left. All right, when you're done with your offset, make sure to choose the checkbox at the top. That logs the geometry of the position. Here I could fill out my attributes. All right, there we go. I am all done. I'm gonna hit check. That stores my feature and it is off to the cloud, to the Trimble cloud.
We will now take a look at using Trimble Business Center to manage some mobile mapping data for fiber optics. Whether you're mobile, take to the skies, or need to walk the streets, NEI has got you covered. Next, we will look at an overview of the GeoSlam product, the Zeb Horizon. Next, we have the Trimble MX9, the latest and greatest mobile mapping solution. Thanks, everyone. Visit us today at neigps.com. And remember, we've got you covered every step of the way.
All right. Thank you, Kevin. Thank you, Eric, for your featured presentation and absolutely outstanding look at all the geospatial applications available from Trimble and NEI. Now it's time for a quick door prize. Number 31. Miss Darsha Rauf with the Arkansas Department of Health. Are you online, Miss Darsha?
Wait, yes, I am.
Okay, absolutely wonderful. Congratulations. You have also won one of our door prizes donated by ESRI, a gift bag, which again, I have not seen, so I can't tell you what's in it, but we will get that out to you following.
Yay. Thanks, guys.
Absolutely. So it is now my pleasure to introduce our next presenter, Mr. Craig Best with the U.S. Census Bureau.
Hey, Chad, thank you. Let me see if I can get my screen shared. That'd be good. All right, hopefully you all can see my screen.
Looks good. You're good to go, sir. Take it away.
Thank you very much. As Chad said, my name is Craig Best. I'm a geographer with the Chicago Regional Office of the Census Bureau. Those of you who may know me, I've been around the Arkansas parts, if you will, for about 37 years with the Census Bureau. I'm actually stationed in Kansas City as a full-time work-at-home employee. So it's not a COVID situation. I just normally work from my home office. So today I'm going to talk about briefly about several different topics I was asked to discuss today. Apportionment versus redistricting, plan for 2020 census data products, metropolitan area definitions and designations, urbanized area definitions, and I'll wrap up with a little blurb on the count question resolution program. So as you may know, hopefully some of you do know this, the apportionment process is the process the Census Bureau is involved in to apportion the 435 seats in the U.S. House of Representatives to each state based upon the not 20, but the most recent decennial census state population counts. That's the process of apportionment. Redistricting then is the process of delineating or defining areas based upon this data. And when I say areas, I talk about things like U.S. congressional districts, state legislative districts, city council districts, school districts, and so forth. Apportionment is a Census Bureau function. Now, the Census Bureau provides data that is used for redistricting, but redistricting is not a Census Bureau function. We provide the information to the people who want to do redistricting, and then it's up to your own state or local laws to create your districts as you are required. So products, y'all might have heard products have been delayed a bit, and this is the current schedule for the release of our data products. The apportionment counts are normally delivered to the president by December 31st of the year that we conduct the census. Due to delays related to COVID shutdown, the new scheduled date for that release is April 30th of 2021. So that's 9 days from today. At least that's the last I've heard. I'm not in the know. You might know more than I do about it. But the last I heard, I think we're going with April 30th is what I'm expecting. And what we do, we provide the counts to the president. That's the U.S. population count, the state population count, and the number of seats each state will get in the House of Representatives for the next 10 years. We've also released our geographic support products. Those were not as impacted by COVID situations as the actual numeration of the census. We plan to release those by February 1st of this year. We actually got all those products released by February 12th of this year. They're available for consumption from the Census Bureau website in a ArcGIS shapefile format. This includes things like the county boundaries, the city boundaries, township boundaries, all of the legal boundaries as of January 1st of 2020. It also includes things like census tract boundaries, block group boundaries, and block boundaries for all of Arkansas and, of course, the entire nation. So that product is out there. I don't know for sure. I imagine GeoStore folks might have grabbed that and processed that on their website, but if not, it is available from the Census Bureau. The next big thing after the delivery of the apportionment counts and the geographic support products is the actual data, the actual population counts at low levels of geography. And I'll skip down to the last line first. The official, I'm air quoting here, the official release is normally by March 31st of the year after the census. Again, due to COVID delays, that date we're talking about is September 30th of this year. And that's the release of the product. It'll be available on the data.census.gov website. That's kind of the official release. Since there have been delays resulting from COVID, and that's caused some problems with states needing to do their own redistricting, we are releasing what we're calling the legacy format. That will be mid to late August that will be available. Now, the legacy format is the exact same format we released the data in last census. So it's good data. It's the same data that will be released on September 30th, although it's in the different format and it's not available for downloading from that data.census.gov site. But you can go to the Census website, download that. It's a pipe delimited ASCII file. You can import that into an access table that's provided with the downloads, and you can do whatever you want with the data you might normally do. If you processed it last census in this format, you're probably familiar with the format and comfortable with using it. But again, I want to emphasize that's these same numbers that'll be released at September 30th, the official release. The only difference is the format of the data. Now let's talk a little bit about the differences between apportionment and redistricting products. As far as the geography is concerned, the apportionment product, the largest is the state level and the smallest is the state level. We only provide the state level population data. The redistricting data, or that legacy data we've talked about, is released at the census block level. That's the smallest level, and up to the state level. So you can go in and find out population, housing units for census blocks, census tracts, block groups, cities, counties, townships, up to the state level. Now, the who is counted in these different products is different. For the apportionment product, the Census Bureau includes the resident population, of course, and the federally affiliated count overseas. These are people that are federal employees that are stationed overseas, and their home agencies have a record of the state of residence for those people. In that case, the population gets attributed back to that state for the purposes of apportionment. That's the determining the seats in the House that will be assigned to each state. But once we get to the redistricting data, we do not include that federally affiliated count overseas. It's just the number of people that were residents of the state of Arkansas as of April 1st of 2020. So the apportionment is just total count only. The redistricting data includes race, ethnicity, and various other characteristics. Disclosure avoidance does not apply at the state level. It will apply to the lower levels down to the census block level. I'll talk on our next slide a little bit about disclosure avoidance. Disclosure avoidance, or this differential privacy, is the Census Bureau's method to protect the data, the information about people for the 2020 census data release. One of the things we found is that with more powerful computing equipment, along with other available data products on the internet, that people could actually take that information, compare it to census information, and even potentially identify specific information about individuals from the census data products. So this disclosure avoidance process for this census is a little bit different. What you will find at the block level is some of those numbers might not actually represent the actual count the Census Bureau determined during the decennial census. But as you add up blocks to get the higher levels of geography, the counts become more accurate. Again, till you get to the state level when we don't have the disclosure avoidance applying at the state level. So it's kind of a complicated topic. I'm not an expert on it, but detailed information is available on the census website about this. And we're actually close to, I think it's next month, we release some final information on the exact plans for the differential privacy for 2020 census. There are some invariant variables. These are variables that will not be changed by this data privacy policy. Total state populations, one. Housing unit count by census block is another. So the block count of housing units is unchanged by the census, although the population will be changed by this process. There's a couple of links at the bottom of the page for more information about disclosure avoidance. You can actually go to the census website, www.census.gov, and search for disclosure avoidance to see more information. Real quickly, I've had some contact from people about our census blocks, noticing that we have fewer census blocks this census. We actually received quite a bit of feedback after the last census that we had too many blocks, and some of these blocks really didn't help the data product at all. So for 2020, we were actually able to reduce the number of census blocks nationwide by about 3 million. And one of the examples we show here is the blocks on the left in orange in the water area. You can see there's quite a few blocks created by the various lines in the census file. And then if you look to the right in green, you'll see many of those water blocks have now been eliminated. So across the entire country, we've eliminated 3 million census blocks. So they will be reduced. I was asked to talk a little bit about metropolitan statistical area definitions. For those of you who don't know, it's not actually even a Census Bureau program. Metropolitan statistical areas are defined by the U.S. Office of Management and Budget. So what that means is OMB delineates these areas according to published standards. Those standards are then applied to the Census Bureau data. So that's how we determine what is a metropolitan statistical area. Federal Register notices on this topic were issued on January 19th of this year. So the Federal Register notices the way the Census Bureau, or actually all government agencies, provide information about upcoming projects or products. And OMB released one on January 19th of 2021. At the bottom, you can see the URL for the Federal Register, quite simply, federalregister.gov, and search for metropolitan statistical areas. And you'll actually be able to get a PDF file of the plan that OMB has put forth for based upon the 2020 census data. One of the big changes is that the minimum area, minimum urban area population to qualify for a metropolitan statistical area, they are proposing an increase from 50,000 to 100,000. So it's a bit of a change for this census data. We're projecting June of 2023 when the finalized criteria provided to us by OMB. We'll apply the criteria and create products for metropolitan statistical areas. So it's still a couple of years down the road for that. Urbanized areas are something the Census Bureau creates. In fall, we published proposed urban rural criteria in the Federal Register. That's also federalregister.gov, and search for urbanized areas for more details about that. We anticipate next spring producing the list of qualifying urbanized areas or urban areas. There are quite a few different changes that were proposed in this particular decade for urbanized areas. I've got some of them listed there. We're going with the housing unit population density instead of the people density, persons per square mile. So we're changing that a little bit, mainly because it aligns better with our plan for disclosure avoidance. Anyway, a couple other topics on there on some changes, but if you're really interested in that, I recommend you go to federalregister.gov and get a copy of that PDF file. Count question resolution, or CQR, is actually the next census geography program, if you will, that will come up. A CQR is an opportunity after the census to report errors in the census count. This program is scheduled to run from October 1st of 2021 through September 30th of 2023. It's open to active and functioning governmental units. So in Arkansas, it's open to every city, every county, and of course to the state. Boundary changes that occurred prior to January 1st, 2020, that were not submitted in time for the census can be submitted under the CQR program, and the count will be corrected as a result. Excuse me just a second. Something called geography allocation errors, where we counted the housing units, but we may put them in the wrong block, may have been just outside of a city limit when it should be inside. Those are examples of other errors that can be corrected in CQR. And census processing errors too, where we might have inadvertently added or deleted a housing unit and the associated data. Those are things that can be corrected in the CQR program as well. If you participate in the CQR program, be advised it will not revise the population data sent to the president. We don't revise the redistricting data that has already been sent to the state, which again, that's August and September of this year. So we don't revise that. And the data available online from the Census Bureau through that data.census.gov site, that data is not changed based upon any updates from CQR corrections. The Census Bureau will produce errata documents. Those are available on the Census website if an entity has a changed population count or housing unit count based upon the CQR program. In CQR program, we do not go back out into the field to conduct a census. We don't go back out in the field to collect any new data. We're working with information that was already collected that we can make educated guesses on, do the research, find the problems, make the corrections, and then move forward with it. I said that really quick, but there's my contact information. If you have any questions, you're certainly free to email me, and I'm willing to take questions at this time.
All right. Thank you, Craig. Excellent presentation. Let's see if we have any questions for anyone. Again, feel free to use the chat or your live video function.
I see a question from Jonathan. Could you comment on potential data degradation due to differential privacy, which could lead to inaccurate counts? Unfortunately, no. I'm really not an expert on that to really comment on that, to be honest with you. It's, I mean, here's the situation with data privacy. If you release all the information, it's got 100% detail, 100% accuracy, but we've disclosed information about people. If you go all the way to the other extreme, then we don't have good accuracy. So what we're looking for is something in the middle where we can protect information about people and still have a good quality product. And that's the part that we're trying to determine right now, exactly where that line's going to be for us. And as I mentioned, we're still working on the final rules, the final algorithms, if you will, for the differential privacy, and data products will be available, sample data products available in the near future on that.
All right. If anyone has a question for Craig, now is your one and only opportunity today.
Craig, this is Elizabeth Bowen. Question about the privacy disclosure. Will we be given, at a block level or at some level, the accuracy, plus or minus 5%, plus or minus whatever? Has that been determined yet, that we'll be notified at each level of data what the accuracy of each individual data set will be?
Yeah, I think they will provide that in a term we're calling the privacy budget. But again, I think more details on that are coming out later. But I think if looking at a percentage of accuracy at a given block, I don't see that as being a product we would release. Just kind of an overall, here's the budget that we work within for each geographic area.
Okay, thank you.
You're welcome. Zip code tabulation areas, yes, they will be updated as a result of the 2020 census. I'm going off the top of my head, I think that's a 23 release. Plan for that to be released in the summer of 23.
All right, great. Well, thank you everyone for your questions, and thank you again, Craig, for an excellent presentation.
Thanks, Jeff.
So, time for one more prize drawing today. Row number 12 is Katie Hadenhauer. Congratulations, you have also won an ESRI gift bag. Are you online with us, Katie? try one more time here. 68. Lisa Caddy with the University of Arkansas at Fort Smith. Are you online? Good things come in threes, as they say. So one more attempt here, number 35. Brandy Dye, Ashley County 911. Are you with us? So I'm guessing all of you that are online and not winning, you're very excited when this happens because it's one more chance you're going to win, right? Eight. Chris Kelly, Arkansas Department of Agriculture, Natural Resource Division.
I'm here.
All right, Chris, congratulations. You have won an ESRI gift bag.
Appreciate it.
Absolutely, sir. All right. Well, speaking of ESRI, coming up next is another sponsor of ours, ESRI. And thank you for all of your gift bag donations today. Our presenter, Chase Fisher.
Thanks, Chad. All right, everybody. Hi, I'm Chase Fisher. I'm a solution engineer for state and local government out of the St. Louis regional office. I want to thank you all for letting me present to you today. Today, we're going to be talking about drones, particularly working with drones and imagery using SiteScan for ArcGIS. Drones provide a new perspective. They're safer, lower cost, and easy to use. Well, anytime we or any organization could find a solution that encompasses these values, it almost always results in a return on investment or ROI. The implementation of drones has proven itself over the last few years to be a great solution to a multitude of work tasks that we have in state and local government. And it's no wonder that we've been seeing such widespread adoption across the country. So where are we seeing our state and local governments using drones? We're seeing them in many ways, from planning, inspections, quality control. We're also seeing them in things like parcel mapping, change detection, search and rescue, fugitive apprehension, wildfire mapping, and wildlife mapping, just to name a few. And when it comes to drone collections, we offer two main products. A product you may be familiar with is ArcGIS Drone-to-Map. Drone-to-Map is an on-premise image processing application. It's great for situations where processing needs to be done either on site or in a disconnected environment. The second one you see here on the screen, and the one we're going to focus on mainly today, it's called SiteScan for ArcGIS. SiteScan is for ArcGIS is a cloud-based imagery processing application. It also has flight and fleet management capabilities and a multitude of in-app analytical capabilities as well. Direct connection to your ArcGIS Online or enterprise environment, and even a direct connection to Autodesk. So SiteScan for ArcGIS, it can deliver accurate 2D, 2.5D, and 3D data outputs in many different formats. You can create digital orthomosaics, digital elevation models, 3D point clouds, meshes, oriented oblique imagery. We have the ability to do thermal orthomosaics as well, high resolution 360-degree panoramic photos. And I think you can see how all these products serve to meet varying needs of organizations. And we'll talk about that a little bit further. So we built SiteScan to be a complete solution for your drone, for data capture, for fleet management, for processing, everything, as well as for analytics of your data. So in essence, what we wanted to create for you guys is a complete drone platform that leverages your existing investment into ESRI. When we talk about an end-to-end process for conversion of drone imagery into information products, that workflow can be broken down into 3 main steps. The first step is the plan and capture step. This is performed by SiteScan Flight app. Using the app, the user can quickly create flight plans that are relevant to the type of site or asset being captured. The iPad connects directly to most commonly used drones and sends the flight plans to the drone's autopilot for execution. After a flight completes, the images are then transferred over to the iPad and then uploaded to the cloud via mobile or Wi-Fi connection. Next, step 2, the images are processed in the cloud and the data outputs are generated. When processing is complete, the user will get an email letting them know the results are available and be able to view that in a web browser. In this web application, the user can not only view the data, but also perform some analytics, measure in both 2D and 3D, volumetrics, PDF inspection reports, analyze change detection, all right in the browser. And for the third step and final step is dissemination and collaboration. For those advanced analytics or workflows that can't be done in the browser, it's easy to either download the files locally to your computer or publish the data sets directly to ArcGIS Online or your enterprise portal. And like I said earlier, SiteScan is what we want to be is a complete drone platform, leveraging your investment in ESRI and also your investment in Autodesk. So your organization can now leverage its investment in Autodesk as well. If you have an Autodesk workflow, you can publish directly to BIM 360 from SiteScan or use the ArcGIS Autodesk connectors. So let's take a look at these steps a little bit more in detail. When collecting imagery with all the right parameters, it may seem complicated. If you're new to flight planning, letting the robot be a robot is a completely new concept. And I understand firsthand. Turning your drone, your expensive piece of equipment over to computer can be nerve-wracking. But when you do it, you realize that you get a much better result. Letting the robot be a robot allows you to create information products that are high quality. And with SiteScan for ArcGIS, we have the flight planning capabilities that we lacked before. We baked a lot of things into this, and we'll talk about this a little bit further in the next couple slides. But even with that, one thing I wanted to touch on is the low barrier of entry. Now, these drones are getting more or less expensive. I want to say more or less expensive. They're getting less expensive all the time. So a lot of the things we're going to show you can be done with a $1,500 DJI Mavic drone, utilizing the software and photogrammetry techniques. So the SiteScan Flight Planning app, it's a cloud-connected iPad app. It connects your project teams and drone operators, easily plan and execute autonomous drone mapping missions. Any flight that is done in the application is automatically recorded in the cloud, along with any information about the pilot, the aircraft, the batteries. All that information is recorded. So this is important information, and it's key for organizations that are looking to scale a drone program to maintain accurate records of their operations. And safety being a priority for most, it's important for organizations to allow the drone operators to follow these regulatory procedures. To ensure that the pilots follow these procedures, SiteScan allows drone program managers to create custom checklists. This will prompt the pilots to complete the checklist before taking off, record their responses. They're saved to the cloud along with all the other fleet management information. Now, the app being connected to SiteScan and ArcGIS Cloud allows drone operators to save and share their flights between project members. This ensures consistent data is captured over time, regardless of who's operating the drone, gives you that apples to apples comparison upon flights. And additionally, this means that your team will always be planning their flights using the most up-to-date information. Previously captured ortho maps are automatically overlaid on top of the satellite imagery. Additionally, any 2D or 3D data you have can be added from ArcGIS Online or portal to provide the pilots with more information before executing their flights. As you can see in the example, this vertical flight plan had to be altered because it was going to run into the buildings. Having the 3D data allowed them to change this vertical scan and collect it in a much more efficient way. For flights in areas with varying topography, we have a new option. It's called SiteScan's Terrain Follow option. This uses ESRI's World Terrain data set. So it automatically plans a flight that'll follow the ground at a consistent height. And it not only improves the safety, but it enhances the quality of the data being captured. So using this is a really nice function in areas with varying topographies. This helps also ensure that your ground resolution, your image overlap, and everything is maintained throughout the flight. So let's take an actual look at site scan flight with terrain follow. So here in the office, we're planning a flight. This is a flight to capture a 3D model of a dam in Northern California. Using the area's survey flight mode, we simply trace out the boundary of the area we're interested in and enable terrain follow option. Now, a pilot can preview the flight plan in 3D. The pilot is also provided with the estimated flight time, resolution, number of batteries, so on and so forth at the bottom of the screen. The flight can then be, once it's been reviewed, can then be saved for future use or for a different pilot to go in the field and execute it. If the flight's being conducted in an area without cell phone coverage, an offline base map can be downloaded to the tablet if need be. And once on site and connected to the drone, the pilot will retrieve the saved flight plan. And after performing a few final reviews of the flight plan, making sure that there's nothing unforeseen in the way, the pilot can be prompted to complete the customized pre-flight checklist. Record all the organization's mandated items, such as the name of the visual observer, or anything else that it needs. And additionally, a safety briefing can be provided after the pilot has reviewed everything in the app. After the safety briefing is reviewed, the app does its own automated systems check before the drone takes off autonomously and begins the mapping mission. Now, the flight is completely automatic. The pilot can monitor the drone video feed live or visualize the project process in a 2D or 3D map. And once that mission is complete, the drone will just automatically return on its own. It'll finish to its endpoint, go to its desired altitude, return, and land. Now those images can be transferred onto an iPad, either wirelessly or via the SD card reader, and reviewed for proper quality coverage before being uploaded to the Site Scan Manager cloud for the processing. So the Site Scan Manager cloud. So the Site Scan Manager is a web application. It's a complete tool for analysis and collaboration. We've completed the data capture, and now we're going to discuss how we're going to manage that data. This application gives the user complete control over the data that was collected by the drone and provides an easy way for the project teams to visualize and analyze the data in a cloud environment, not in a siloed local computer. One of the benefits of this cloud-based application is that everything's immediately available across your organization without the need to download massive files. We've designed the Site Scan Manager to be accessible to all your team members, even the less tech-savvy ones. The web interface offers 2D and 3D viewers and a variety of analytical tools that allow your team to perform a majority of the common tasks you'd want to do with drone data. Overlays, measurements, reports, annotations, sharing with colleagues, so on and so forth. This should all be done with little or no training. And to make your drone imagery truly valuable beyond providing an up-to-date view of the site or inspection photos, it's critical that your team trusts the accuracy of the data outputs. That's why we've built in tools that can make it easy to tie your data to survey ground control points or GCPs. This can be done through an assisted or manual workflow. It can be fully automated through computer vision detection of your ground targets, and the process outputs will be converted and delivered to your project's coordinate system, whether it's a known or a local one. The measure and validate of the accuracy of the results are independent and validated within the processing report. It's delivered for every flight, and to access the quality of these processing reports, it's very simple interface. For those of you that's wanting to use like RTK or PPK enabled drones, such as the Phantom 4 RTK, SiteScan also makes use of that enhanced geolocation accuracy of all the images to provide a higher accuracy output, whether or not you're collecting GCP. And with that, let's go into a demo of how SiteScan Web App Manager looks. So now that I've logged into SiteScan Manager, through the standard web browser, I can view the projects I have access to on the map or in list view. Here's the San Pablo Dam project that we did earlier. we can see that we have 2 missions that have been completed on this site, including the one that we just saw captured. So for this mission, the results took about an hour and a half to process. I can view the photos or the updated orthomosaic, inspect them for quality and accuracy. As you can see, they stitch together really nice. I can also display the elevation data as a heat map, which has a slider bar on it. It's really functional, and or see the contour lines. And this can all be exported for use in CAD or other GIS software. We can use this timeline tool to compare apples to apples between the 2 different flights or a multitude of different flights since you're repeating these flight processes. You can also view the point cloud with no need to download any data. In here, there's several tools available that I can easily measure height or generate a profile view of the site. And as you can see, it renders fast and very efficient over the web. Once you've done your measurements, there's a lot of different ways to export or download the outputs. As you can see here, this is just a section of the LAS file you could actually export, but you can also just click the export and export the information here or publish to ArcGIS Online or Enterprise. But now we're going to jump over to a completely different project. This one is actually over in Japan, where a new water reservoir is being built for one of our customers. I can give you a quick tour of the site using the 3D mesh viewer, integrating the imagery and that LAS file. And here we're just looking to gain insight on progress for ongoing earthworks. The project manager has uploaded 3D grading surfaces, which can be compared against our drone data and generate a cut fill heat map. Users can define the ranges within this heat map so that the data suits the way that their team needs it. The elevations, the deltas, or volumes can be displayed on the map or even in a grid format for more detailed quantification of the specific areas. You can use the volume tool to trace out a boundary and display that area in 3D. So in here, we can choose our comparison surfaces and get detailed cut fill values in seconds. This is a process that would normally take a trained CAD user 10 to 15 minutes to complete, not including data download time. And now it can be done in just a few seconds by virtually anyone. You can expand this area and see that they still got quite a bit of dirt to remove. This just gives a full scope of the project in seconds, whereas, like I said, it would take a long time to do in the past. And lastly, let's look at our newly completed Denver office and show you some of the site scans inspection tools. From a 2D view or a point cloud view, I can use photo inspect tools to find all photos displaying a specific point. I can also look at those mostly closely matching my current view angle because they're prioritized. I can view the photo in full resolution and also make comments on that video or that photo for whatever needs to be done. And that also can be exported as a PDF inspection. So you can get information done on the site. And with that, let's now discuss the last step of our drone data workflow: disseminate and collaborate. Your users can, of course, simply download the outputs for local use, but you can also conduct advanced analysis of your data by leveraging the ArcGIS platform. In ArcGIS Pro, for example, you can use AI or object detection tools to perform video analysis. You could also utilize data through custom web apps or dashboards, or an ESRI suite of field applications. Or, like I mentioned earlier, you could utilize Autodesk environment through the ESRI Autodesk connector. So Q2 and Q3, the roadmap ahead. We already have completed the enhanced support for the DJI Phantom for RTK, so it is currently supported. Shortly, or it may already be done already, the support for the FreeFly Astro should be done. We're upgrading our enterprise fleet management capabilities, implementing 3D scene viewer capabilities, and one of them I'm really excited about, the in-frames mesh engine. ESRI company acquired a company called Sure. Sure is a German-based company. Most drone photogrammetry processing takes place usually utilizing different engines, one of them being the Pix 4D engine. This in-frames mesh engine is a very powerful engine, and I've seen some of the detail that can come out of it. This is going to be baked into the back end of SiteScan as well as Drone2Map to create very high resolution mesh engines or meshes in the future, hopefully before the end of the year. We're going to integrate some markup tools, and then also the ArcGIS login using a single sign-on. Currently, SiteScan is a completely separate organization. So you would log into it. We have unlimited hosting, unlimited storage, 2 levels of licensing, an operator or an access license, and unlimited viewers to access this data in the cloud. So we have a lot of things that a lot of organizations don't offer when it comes to drone management. And one of them, one of the other issues was publishing behind an enterprise behind a firewall. We've got a workaround for that, but they're going to streamline that process as well. And with that, I just want to leave you with my contact information here. If you have any questions about drones, I urge you to contact me. We can talk through this. We can talk about what you're going to face, what's coming up. There's a lot of things in the roadmap ahead that I love to talk about. One being they're talking about integration in near real time view the video feed from the drone in SiteScan Manager. So for EOCs or any of that stuff, we could actually potentially have the live video feeds or near real-time video feeds of the drone. We do have integrations with quick capture so that you can, while flying the drone, if you see a point of interest, a subject that you're searching for, or just want to mark things like the edge of a wildfire, we can connect quick capture to the X and Y of your drone and drop points or draw lines with the drone on quick capture. So if it's a search and rescue situation, you could utilize that to put a point on a map. Anybody in the field using field maps could get turn-by-turn directions or foot-by-foot directions to that point of interest. There's a lot of capabilities, and we're continuing to expand on them every day. So with that, I will open it up for questions.
Hey, Chase, good to see you again. This is Sam from Washington County.
Hey, Sam.
Hey, man. Do we need so at the county we do have license for the portal and the enterprise and the online. So does this require the site scan? Does it require a separate subscription? And
yes, it's currently not included with an enterprise license. And like I said, it's sold in 2 user types: the operator or the access license. Operator is required to actually take off with the drone using the flight planning app. However, SiteScan itself can process drone imagery from almost any drone not using the flight planning app. So it's still a processing component that works just like Drone2Map.
I've used Bixd40 and F4. I can, if I can, what's the equivalent of this? If I can start from do everything from start to finish, just fly, analyze, and get the data. Do I need both the services?
Just the operator license will get you everything.
Operator.
Yeah,
and
access is created just for those people who want to manage a drone operation but don't fly.
Okay.
And then the viewers are free.
And it's the quote, the price on it, it's different by organization, or it's a flat rate?
It's pretty much a flat rate. I don't quote me on prices, but typically typically what I've seen is approximately $5,000 per year for an operator license, $500 for access.
Okay.
And all that's needed to have a SiteScan organization is 1 operator license.
Okay, got it.
But as you increase in numbers, we got the state of West Virginia, state of Kentucky, we've got people that have full statewide operations. As you increase in the number of operators or access, that price can decrease.
Okay. Yeah, and I still have your card, so I'll send you an email.
Yeah. Just shoot me an email. No problem.
Absolutely.
Any other questions?
Hey, Chase.
Yeah.
Malcolm Williamson, CAS at the University of Arkansas.
Hey, how are you?
I'm good. Do you guys have any higher ed pricing worked out for this at all yet? We don't need to discuss it here, but I was wondering if it's been addressed.
Shoot me an email and I'll reach out to an account manager and
okay,
we'll see. I don't know if they've had anything. It's a newer product. It's not brand new anymore, but it is a newer product. So I don't know if they've worked that out. I assume just like everything else we have, it'll eventually get baked into discounts for enterprise and stuff like that. But as of right now, I'm not for sure.
Okay, sounds good. Thanks.
There was a few things that I wasn't able to touch on in the videos. If you guys would like further information about the thermal imaging, the volumetrics analysis, there's a lot of different things that we couldn't go over in just the short amount of time. So I'd be happy to do a more in-depth dive, show you it live if we need to. So like I said, reach out to me or your account manager, and we'll be glad to help you.
All right. Thanks so much, Chase. That was an outstanding presentation, invaluable information. I want to thank you and ESRI, of course, for your sponsorship today. And speaking of, it's time to give away yet another ESRI gift bag. All right. Final ESRI gift bag drawing for today will go to Jamie Nash, Arkansas State University. Jamie, are you online with us?
I am. Can you hear me?
I can. Congratulations. You have won the 5th and final ESRI gift bag for today. So congratulations to you.
Thank you so much.
Absolutely. All right, and now for our final presenter of the day, we're going to turn things over to Mr. Robert Reed with ARDOT for his presentation, Square Peg, Round Hole.
Thank you, Chad. I appreciate it. I tell you, I got a little excited there because I was just one number above 16 and I thought I was about to score a gift bag. And
well, there's one more prize. You may win that $25 Amazon gift card coming up next.
All right, I'll hold out for that. I'd like to thank everyone for attending today's meeting. I am going to be talking about something I think everyone has dealt with, which is kind of, everyone can relate to the idea of being asked to accomplish a task or a project and having to come up with a solution. Most times you have to kind of rely on what you readily have available. Sometimes those ideas really work out, and sometimes you kind of look back on them and maybe they didn't work out so well. And that's what this presentation is going to go over, is a few examples of solving a situation with what you have available at the time. So this first example was a request that came from one of our staff archaeologists. And he asked for the capability to take a photo of a culvert from on top of the roadway. Now, like everyone watching this, many times we get requests to work on things that may not already have a set method for accomplishing them. And we sometimes we scramble to figure out a way to do it. And sometimes, we have a little more time to figure it out. This is one of those times where you're kind of scrambling to figure out something to do. So, as everyone knows about drones, we just had presentations from Kevin with NEI and Chase from ESRI, 2 great presentations that discussed drone capabilities. Drones kind of become something very common, something like a quadcopter drone here. Everyone can, probably is either used one personally or seen one in action, and it would have worked great for this project. We could have taken the drone and flown it level with the culvert and taken a photo, and the person flying the drone, if they were brave enough and maybe not financially responsible, could have flown the drone through the culvert and taken some photos. So this would have been perfect for what was being asked of us. We didn't have access to a drone at this time, so that kind of was not a possibility. So we had to kind of think to ourselves, what do we have available? Well, we had some Trimble Geo7Xs with a built-in camera. We had a Geo7X monopole bracket, and we had the monopole. And so we got to thinking, well, what if we took the monopole, took the monopole bracket and attached it, took one of our Geo7Xs and attached that to the monopole bracket? We would essentially be making a version of a spatial selfie stick with this. So we thought, let's give this a try. Let's give this a shot. Maybe see if he's even game for trying this. And he was. And so we came up with the process. Now we knew the first step was going to be that he wasn't going to be able to push the button on the Trimble to take the picture with it attached to the pole. So the first step is we actually had him go in there to the camera app and switch it to video. And so as he's running video, that was the first step. And the second step was the more important of the two steps. It was to flip the monopole upside down and to essentially take it and hold it down in front of the culvert from on top of the roadway. Now from that video he captured, we were actually able to take a screenshot as a still frame for the picture we used. And honestly, surprisingly, it worked out pretty well. We were able to send this to him and he was able to use this for whatever purposes he needed it. And it worked out pretty well. So this is one of those times where things worked out. Another thing we run into is, working in environmental division, we have to work in a lot of areas that might not be what you would call GPS friendly. Now, of course, this all changed with the GNSS, but this is kind of a time where it was only the GPS constellation available. We'd run into areas that maybe you'd run into something such as an obstruction in that one picture there with the cliffside, or maybe we'd be in areas of dense vegetation, essentially a lot of reasons that might block visibility of the sky with our units. Now, back in this time before GNSS, before RTX, Zephyrs, all that, we used the GeoEvent series and the Pro XR series, and we also used a Contour XLR laser rangefinder. So essentially, you would take like your GeoExplorer unit there, you take a serial clip, would attach that to your GeoExplorer, and then you would attach a cable to the Contour XLR, and then you were able to do offsets. Worked pretty well. We used it in that setup. And then we got to thinking, we've got the capability to do offsets. What if we use the laser rangefinder in areas that we expected to have difficulty getting good signal? Do a little mission planning where we could possibly set up the unit and our, collect signal in an area that had better visibility to the sky, and then shoot the laser rangefinder into an area that was more, obstructed by tree coverage or whatever that would make it hard to get signal. And then once we started thinking about that, we got to thinking, what if we made a target to use with the laser rangefinder? This would give us something we could take with us all these times, give us something repeatable, so we could always have the same target we knew that would provide us something to hit with the laser rangefinder. And so that's what we did. We, being in the highway department, we have no shortage of reflective sign material. So we took some reflective sign material and we covered a piece of foam core board with it, and we attached it to a pole. And so now we actually have a target that can be taken anywhere in the field, set up, and we knew we'd have a repeatable target that we could hit with a high reflectivity to get a good signal from the rangefinder. So we thought we were really onto something with this. This has been used total number of 0 times. It's actually in a closet somewhere at the office, tucked behind a cabinet, I think. This is one of those ideas that might have sounded better on paper and didn't really pan out so well in application. Now, this example here is actually not from our section. This is actually from one of our biologists. He would do bird surveys under bridges to see if there were any birds nesting when we were going to work on a bridge. And so he actually constructed this mirror on a telescoping pole that he could actually use to raise above a nest with it, so he would not be disturbing the nest, and could see if there's any eggs there. And so, and I think this is still maybe even used to this day for doing bird evaluations when working on bridges. I mean, it's a pretty ingenious thing he came up with. Now, as you all know, and I know you've all been in the situation, sometimes you're asked to accomplish something and you have a limited time frame. You have to come up with a solution pretty quickly. There may be multiple ways to accomplish what you're doing, but right at that moment, you just need at least one of them that works. This next example is one of those times where we had a fairly quick turnaround we had to deliver on. We were given an Excel file that had 633 records that had already been evaluated. However, there were no latitude, longitudes, no coordinates of any kind in this Excel file. We also had a feature class that had 5,711 features in it that these 633 records had been pulled from. The thing we were having to do is we needed to find that 5,078 features that had not yet been evaluated. But how were we going to go about this? Well, one idea was, fortunately, both the Excel file and the feature class had a field in common, had an ID field in common. So they shared that data. So what we could do is we did an attribute join of keeping only the matching records between the two, and it resulted in a layer showing the 633 features in common, as you can see here. But we already knew those were evaluated. We're needing the other ones. So we brought back in the original layer into ArcMap. Did a select by location query that allowed the features from the original layer to be selected from the same features that intersected it based on the joined layer. And since the layer being used was exactly the same one as, the same layer was being intersected with itself, the points were in exactly the same location. So they matched up exactly. So it selected those 633 points. And as you can see here, when we look at the attribute table, that's exactly what happened. It selected the 633 points that had already been evaluated since they matched up. But we don't need these points. We already have these. We know they're evaluated. So then stepped in one of my favorite tools in the whole ESRI world, the switch selection tool. And using the switch selection, it actually selected the 5,078 that we needed from before that had not yet been evaluated because they were not the ones that matched the intersecting points. So after I got through doing this, I went and spoke with a couple others in my section, kind of saying, this is what I did, what did y'all think? And one idea they came up with is that they would have actually kept all the records from the join, and then they would have manually deleted the records that had values in both fields, which would have been the matching records. And that would have obviously worked no problem. And then it was pointed out that their method was kind of a manually driven method, manually deleting the points, whereas the method that I had used could be automated. So for example, if we ever needed to do something like this, maybe to repeat this, if it was ever, that layer was ever added onto or needed to do it in case more were evaluated, it'd be an advantage that we could put it in possibly a Python script or a model or something of that nature. Now, my last slide is actually one from UCA. I have the good fortune of being an adjunct instructor in the graduate program in the geography department. And we were working on an assignment. And part of that assignment was for the class to take a string value that in a field that came before a comma. Now, the neat thing is, there were 4 students working on this, and all 4 of them came up with a slightly different way to do that, which I very, generalized there at the bottom, just kind of giving the general steps. But I was just blown away that each one of them did it slightly differently than the other one, but all came up with the correct way. And in my opinion, that's just one of the best things about GIS is that I can't think of one process that only works one way. You can basically at least do something more than at least 2 ways. I mean, that's just, to me, one of the great things about GIS. And I do want to thank y'all for your attention. It was a very brief presentation, but I appreciate y'all watching. And I'll open it up to any questions or any comments or anything.
Hey, Mr. Reed, just want to say, MacGyver is going to be very proud of you, the original MacGyver. Thank you so much.
Thank you so much. I appreciate that. And I do understand that comment.
Yeah, in grad school, we've done lots of crazy stuff, and that's what it teaches you, basically, just to work with whatever you have and limited resources always.
I couldn't agree with that more. That's one thing I tried to stress them. You got to be able to troubleshoot and figure out ways around it.
Absolutely.
Yeah, so I think that's fantastic that you said that.
Thanks, Robert.
Thank you. Thank you, Sam.
Sure.
All right. Well, if there are no more questions from Robert, I would like to thank you, sir, for an absolutely wonderful presentation. I was very interested in taking notes, actually. So
thank you, Chad,
for that. So one more final giveaway for today. This will be what we started with, a $25 Amazon gift card delivered to you electronically. Jonathan Duran, Arkansas GIS office. Jonathan, are you still with us?
Yes, I am still with us.
All right, congratulations, sir. You have won our final door prize of the day, a $25 Amazon gift card. All right, so that's going to wrap up things for today. So just a couple more announcements, our meeting roundup. I would first like to thank our sponsors today, ESRI, and especially NEI for your presentation today and your continued support for over a decade of the Arkansas GIS Users and Users Forum, and Nelson Intelligence Solutions and your contributions today, as well as your participation with the executive committee. We would like to thank all of you. Your sponsorship and support is sincerely appreciated. So the final announcement today, Deano mentioned it at the beginning, and I would like to now go ahead and show everyone what is now available. So we are transitioning from the announcement for the spring meeting to now announcing the 2021 symposium and training. The website has now been updated. So when you visit argisusers.org, the first thing that will splash on your screen is this new graphic with the Learn More link. Or if you go to argisusers.org/symposium, you will actually end up in the same place. And that is the now online registration page. So we are trying to get things moving a little quicker than we used to. So the registration is online, it is live. You can go on right now and register for the symposium. Also on this page, you will find the announcement and the link for the call for presentations. Jonathan will actually be following up after today's meeting, making an announcement about the call for presentation. He chairs our program subcommittee. But the link for that is on this page, and it will actually take you to an ArcGIS Survey 123 form. So hopefully something we're all very, very familiar with. And this is where you will submit your presentation, or the historically call for paper submission. Very self-explanatory form, very easy to fill out, allows for both presenter and co-presenter information. There's also a link at the top to access the User Forum Presenter Guidelines. This is the document that Jonathan and the Programs Committee have prepared, providing you all of the information you need to submit a presentation to be featured and share your GIS story in the upcoming 2021 Arkansas GIS Symposium. So we encourage everyone to don't hesitate, feel free to go online and start that registration process. So with that, once again, I would like to thank everyone for attending today. Unless Deano or anyone on the executive committee has any closing comments, that should complete our presentation and the 2021 Arkansas GIS Spring Meeting. Deano?
I just want to reiterate what you said and thank everyone for joining. And it was a very, very good event, and I appreciate everyone's participation.
Thank you, Deano, and thank you again, everyone. Hope you have a great day.